Wait, okay, everybody, we're next. We got balancing reactions. This is the next video in the series. And again, we've done this a little bit more. We've done this in the beginning of the course for a little bit, but now we're going to pick it up a notch and look at reactions on how we balance a little, some ones that are a little bit bigger. Again, the idea is the same. You're pretty much doing the same thing. It's just that we're going to work a little bit more on it and spend a little time looking at the inside scoop of how we balance. Okay, so number one, okay, so just a couple things. When you balance a reaction, when a reaction takes place, don't forget that there is a rearrangement of the atoms, okay, so of existing atoms. So again, we're using what we started with, right? And then that is rearranged to form the products. So you're looking at rearrangement, number one, okay? Number two, you're going to form something brand new from the rearrangement. No mass is lost or gained during the change, right? So which means both sides of the reaction must weigh the same. Once a correct equation is written, one must balance each type of atom on both sides, not molecule. You're balancing the atoms, really important because many times questions will try to mesh up on this. Make sure that both sides must be balanced. So one has to equal the other. Okay. Now, there's a few ways to do this. All right. And I'm going to show you, one way to do it, but there's also an alternate way, which I might show you here. Okay. Just a couple of things you want to remember. Place coefficients in front of the formulas to equalize each type of element on both sides. Don't ever alter a chemical formula. Okay, remember chemical formulas are written for that particular formula, all right, which represents that compound. When you balance, you cannot alter that. You're not changing subscripts at all here. Okay, so the only thing you have in your arsenal, the only thing you can do is add coefficients to the front as multipliers. That's really important to know. Okay, now you have to make sure that formulas, okay, must be correct. Okay, otherwise, if they're not correct, you may or may not be able to balance, and that's going to keep you. That's going to get you. That could make you very, very frustrated, okay? Because sometimes you can balance the reaction and sometimes you can't. So you'll be sitting there for a while trying to balance it because you have a bad formula. So please make sure you have correct formulas when you balance, all right? So it's important to know, okay? Balance polyatomic ions as a group, okay? So remember, we're keeping those as a group. So remember, polyatomic ions such as sulfate, you want to try to balance this as a group, okay? Think of that as a single particle. We talked about like the polyatomic ions being families. They stay together, so balance them together. So, for example, if there's 3 sulfates on one side, you want to make sure you have 3 sulfates on the other. For most of the time, that's going to work. Okay? And then reduce your coefficients to lowest terms. Okay, that's going to be an important thing too. So if you have a 2, a 4, an arrow, and then a 2 and a 4 as coefficients, you want to reduce this by 2, right? Because everything's divisible by 2. And then you would have a 1, a 2, a 1, and a 2. Again, you're going to come across this as we move on. There's no problem with balancing with high coefficients. Just make sure you take a look later on that you've reduced them if they're reducible across the arrow. All right. So let's just do a simple one. Let's just say you have zinc and hydrochloric acid. Okay, and then we'll have an arrow here. Okay, and then we'll have zinc chloride plus H2. So what I like to do here, is just go element by element and then recheck them. So you have 1 zinc on here at this side, we have 1 zinc on this side. So that's balanced. Okay, then we'll go over to the H's. If you take a look at the H here, you'll see there's 1 H here, and on the other side we have 2 H's because the 2 here means 2 H's. So we have 2 multiplied by 2. So we're going to go over to the other side. We're going to put a big 2 in front of here. Now, again, remember that the 2 goes not only for the H, but it also goes for the Cl, okay? So not only do we have 2 H's, but we also have 2 Cl's. Now, let's just see on the other side. We have 2 Cl's already, so we're already balanced with the Cl's. And that does it. That takes care of all the elements. What I'd like to do, again, go back to the beginning and check. 1 zinc, 1 zinc. 2 H's, 2 H's, 2 Cl's, 2 Cl's. Okay, now you could put a 1, a 1, and a 1 here. That's fine. You can do that. So let's just do that for the first one just to show that you can do that. The only thing you don't want to put is zeros. No zeros. Important. You can't put zeros in front. Of course, that would be multiplying the whole thing by 0, and that wouldn't be good. Okay? All right, so next, let's just say we have KCl. This actually shouldn't be here. That's not good. let's just get rid of that. That's a wrong formula here. So we'll get rid of that one, and we'll have this like that. How about that? Okay, so that's a mistake. We'll take that out of there. Pretend that's not there. All right, so we have KCl and O2 and KClO3. So we have 1K, and we have 1K. We have 1Cl, we have 1Cl. Okay, now it appears that we have a problem here because we have 2 O's and 3 O's. So we have to find something that would make them equal, a coefficient that would make both of these equal. So 6 is probably a good one, right? Because if you take 2 and you multiply it by 3 and 3 multiplied by 2, you can get 6, and that would equalize us out, right? So if we put a 3 here, that would give us 6 O's. Now again, a 2 would have to be here, because then the 2 would also go for that, would make that 6 O's. But then we also have 2 K's and 2 Cl's. So then we can go back in the front here and put a 2K. So we have 2 K's and 2 Cl's. Okay, and that should balance it. So that looks pretty good in that way. Okay, all right. And last but not least is a good question, another one here. We could take a look at this here. And let's just say we have this reaction, and we have 3 carbons here, and then we need 3 carbons here, which is fine. So 3 C's gives us 3 C's. And then we go to our H's. So we have 8 H's here, and we already have 2 here. So if I have an 8 here and I have a 2 here already, what could I put in the front that would make me 8? What times 2 would be 8? Well, 4 times 2. So we can put a 4 there. So we have 8 hydrogens and 8 hydrogens. So far we're doing pretty good, right? So C3, 3 C's, 8 H's, 8 H's, and now we can come here. Now, just be careful. A couple of times you got to be careful because this oxygen is actually in both of these formulas. So we have 3 times 2 of 6 oxygens here, plus, so there's your 3 times 2 is 6, but we also have another oxygen here. So this would be 4 times 1, right? Because it's 1, which would be 4, and that would be a total of 10 total O's on this side. And if we look at the other side, we already have a 2. So 2 times what number would be 10? And we'd have to do a 5. Okay, that's a good way. So actually underneath here, you can give it a good count out. You can always count out your elements below. Sometimes you could set up a little chart, or you can count out your O's. So sometimes what people do is they'll have a chart. So let's just say the arrow is here. You could put C, H, and O and put down the number of atoms you have on one side and the number of atoms you have on the other, and simply do that. So let's just say we started from the beginning. We started with 3 on that side. We started with 8 on that side. We started with 2. So I'm just saying from the beginning, without the coefficients, we would have 2. And on the other side, we would have 1C, right? Starting from the beginning, no coefficients. 2 H's, right? We're going to be 2 H's here. And then we would have 3 O's, right? We would have the 2 and then the 3. And it would be up to you to times these by factors, the coefficients, so that both these are equal and go across the arrow. So sometimes people find this easier to use. I don't necessarily use that method. I think it's just easy just to go element by element. And again, this is a skill, and this skill takes practice. Some people will be really good at it right away, and others will take some time. And again, with practice and with more practice comes perfection on this, and just becomes good. But understand that balancing reactions is a must. Okay, this must be done correctly. It must be balanced in order to be correct. All right, so I hope this helps. Again, we'll have enough practice, and we'll see you soon.